Hello and welcome today exclusively at Airbus at the Safety Promotion Center. We are honored to be accompanied by Yannick Malinge. Hello Yannick.
Hello everyone, I'm responsible for flight safety at Airbus. A heavy task with all my troops, but also with all of our employees. It's not just the privilege of the people in flight safety at Airbus. And that's why we developed this Safety Promotion Center. The idea here is to constantly strengthen our safety culture.
This is the first time you've seen a camera here. Come on, let's go. Let's go.
So here, we're going in.
The Safety
Promotion Center. That's what aims for all our employees to be able to visit this Safety Promotion Center. The idea is to continuously reinforce the culture of flight safety and accident prevention. How many employees are there now at Airbus? We are roughly 100,000 employees on commercial aircraft. We have SPCs in Toulouse, Bangalore, Hamburg, Filton, and other locations. And what proportion of global aviation is Airbus today? To put it simply, for planes with over 120, 150 seats, Boeing has a 50% market share. So
2 billion people
each
year. It's
more than 2 billion passenger packs on the global fleet. Airbus sees increasing risk exposure as air traffic continues to grow, with over 15 million flights to date.
This obligation is essential for flight safety. And despite the increase in traffic, we have managed to reduce the number of accidents in value as well as in absolute, in proportion.
Absolutely.
A simple figure.
In 30 years, we have reduced the accident rate causing victims by a ratio of 30 OK, 30-30. And today, I take the Airbus fleet. We reach an accident rate per million flights of around 0.03. That's one accident per 33 million flights. What we see here, it's simple. It's a certain number of accidents that have been very, very visible to the world of air transport, not only Airbus, of the global fleet, and classified are the major categories of accidents. And it shows how we have been able to improve flight safety by taking into account the lessons learned from each of these accidents. So what are the 5 major categories? So the 4 major categories: loss of control in flight, control flight in all terrain. So there, it's the plane that hits a mountain, unfortunately, while everything is fine. Runway, exertion. So runway exit, mid-air ground collision. These are mid-air collisions. I will speak at the end of the last part here. Who is the safety culture? An essential point, I'm not going to go into detail today, but an essential point is that from all these accidents that had a strong impact at the industry level, we have learned from regulatory and airplane design perspectives, we have learned what additional barriers can be implemented. We have learned from a crew resource management point of view. I have in mind the Tenerife accident, which is the ground collision that led to the advent of crew resource management, regardless of the category of accident. When we look at the evolution, each time we have added technological innovation on board the planes, we have reduced the risk by a very, very significant factor. For each of these categories of accident, typically the loss of control accident rate has been reduced by 90% since we introduced electric flight controls. The Airbus A320 and later models, including the A220 as well as Boeing aircraft, utilize fly-by-wire technology. 777, 787. Flight control improved as systems were gradually introduced, such as the ground proximity warning system. Ground proximity warning system takes into account the radio altitude of the plane, its altitude, its variometer, its descent rate, the plane. We're going to tell the crew.
Have accidents related to breakdowns disappeared faster than ground collisions?
So from one generation to the next, we have improved the reliability of aircraft systems, engine reliability, structure, etc., which has been a significant factor in improving flight safety. And we realized that gradually, by improving the reliability of the systems, the intrinsic job of fly the machine as a pilot has evolved into manage the mission to transport my passengers from A to B. And we see the result of this improvement in reliability of engines, systems, and then the safety barriers that we have added to cover operational safety risks. We see the result on the evolution of accident statistics, where we find, therefore, it's on a rolling average of 10 years, the accident rate with victim We find that each generation differs from the previous one, showing a clear progression.
The first generation had an accident rate of 2.5 per million flights, showing an improvement over previous rates. Second generation, we go down to around 1.1. Third generation, we are at 0.11 and 0.0.
0.03 or 0.04 fatalities for the last generation, depending on whether we consider the large facets or not.
We really have proof with years of feedback that we really have a progressive improvement.
I remember when I started as a young investigator, end of 92, beginning of 93. At that time, the industry. On average, I take all types of planes combined. We have a rate of 1 for 1 million, 1 plane crash victim for 1 million flights. And we were asking ourselves, but if we do nothing with the increase in traffic, it's going to be terrible.
We must do
something. Today, the Airbus family is do it all 0.03. 30 years decrease.
Airplanes are considered the safest means of transport worldwide, being 30 times safer compared to other modes of transportation. Is it also valid in number of flights? I take my car 1,000 times, I take the plane 1,000 times. Is flying still safer than other modes of transport regardless of distance? Yes, it is.
We all drive. Yes, how many times when we drive we observe situations that are almost accident prone? There are about 20 deaths on the road in France today, that's it. So earlier I explained how we improved flight safety with barriers related to the plane to cover operational safety risks. But we also learn a lot in terms of lessons to improve operational instructions. I will take the example of the Hubelingen mid-air collision in Germany, where there it was 2 planes that had a risk of collision that unfortunately materialized. What was the lesson? Yes, we have the traffic collision avoidance system that tells the crews what instruction to follow. Either I go up or I go down to avoid the risk of collision. Unfortunately, in this example, one of the crews was influenced by the message they received from air traffic control. And he did not follow the instruction available on board the plane. A reminder lesson to all crews: when there is a traffic collision avoidance system alarm telling you to climb or descend, you obey that alarm. Climb, climb. In
priority
over the orders that may come from air traffic control. The situation is very dynamic, and that's why it's important to respect the traffic collision avoidance system orders given on board both planes. Do I climb or do I descend? Do I climb or do I stay? Do I descend or do I stay? So next we have here the role of an aircraft manufacturer in an accident. Just like all aircraft manufacturers involved in accidents, engine manufacturers, airlines, air traffic, we are all invited to technically contribute to major investigations to make our resources, our product knowledge available to investigation agencies. So it can range from a simple explanation of operation with curves, with explanatory diagrams of architecture system. We make our test labs available. We can also do test flights if needed. We can also do tests in the labs to go, in quotes, torture structural equipment, see how they respond or not to standards. It is important for us to contribute even when it's difficult. When there are 2 years of research, we must continue. When I lose a piece of the engine over Greenland, we said to ourselves, oh, it's a needle in a haystack, we're going to go, we're going to go, we're going to insist.
A little focus on Flight Air France 66, you might remember. This plane, this A380 that was flying over Greenland. And it had a major fault on one of the engines, which clearly lost a piece. And then it comes back to Airbus and Air France, who have to find this piece at their own expense. They made the efforts to go all the way. Satellite photo with engineers indicating potential flaws or areas requiring further inspection. They send helicopters with a nice H-125 that you recognize. The teams go down and find this piece. And so Airbus contracts with Honera on an experimental radar that allowed to see under the snow if there could be inside the engine. This part here, because that's where there were questions, and that's what was crucial to find. This allowed for analysis and feedback, for even more security. Airbus and the airline Air France were financially involved to go all the way for safety. So,
in accidents, we often mention the orange-colored black boxes. Its range, for obvious reasons, is much easier to identify at an accident site. Airplanes mainly have 2 recorders, a cockpit voice recorder that captures all sounds in the cockpit, and a data recorder. They allow us to understand, and generally we understand very quickly the what. The why, it takes time. This also explains why investigative bodies are required to take time to understand well, to analyze well.
That's why there is a first technical report after 30 days, but the conclusion, the analysis can sometimes take years. Exactly. And it's fundamental, it's
fundamental. Just to illustrate this, it's a very old accident recorder with a magnetic tape that we can see. And there were only a few parameters to record, a few parameters.
That is to say what? It's a few dozen
of parameters
recorded every second.
Evolution of technology. We are discussing the 350 latest recorders. We can see these little chips, these little memories.
Here, these are the memory cards.
Models.
The memory cards, there are
3,500 parameters. So in fact, it followed the tech evolution. What's in all the rest? So all the rest, in fact, I take that, it's much heavier. This is what I call the pressure cooker. It's the part that protects against impact, against fire, that protects the memories, against water, everything else. Exactly. So I no longer have in mind the acceleration values that it can withstand of heat, of pressure, but it's very, very important. And where is the pinger? The pinger is a small component. The ULB is that makes noise to be heard underwater. For 90 days now, before it was 30 days. Ah, yes, it gives more time. Exactly. And behind we see
statistics.
We see the evolution. In fact, we see the evolution, typically 70 to 300 B2, B4. The number of parameters at the beginning of the assertive to the scale, it was less than 100 parameters. Today, I take 100, 350. We have over 3,500 E.
3,500 parameters recorded multiple times per second on this small box.
On this little box. Plus when we can recover calculators and planes that are not protected against shock, fire, etc. But it happens that in some cases of accident, we can recover some calculators, and we do when it's useful. We attempt to read the memories of our calculators, and occasionally, if not severely damaged, we can access them to supplement the information on the protected recorders.
The big data?
The big data, yes. So it shows very clearly why today it's going very, very fast to understand the what happened. Again, the human factor makes it more complicated.
We will have questions. Why didn't we like all these data in the cloud?
With the satellites? Oh, because it would require bandwidth. Different. And then there is the fundamental question of who owns the data when there is an accident. The control, the governance, the control of the accident data. It's important that it be controlled by the investigation bodies with all the risks that it could take if it was actually sent to a cloud, etc. Cyber risks, etc. Risks of capture by unauthorized individuals during data investigation. And then to have investigations, we will say, opened by people who are not necessarily experts with all the speculations that it could generate, etc. For a value.
The ending is questionable. Regardless, there are currently no satellites in space, as not enough have been launched yet. What's more, even if we wanted to do it, we would have to multiply by significant factors the number of satellites in flight, absolutely.
Here, we reach the second stage of the Safety Promotion Center, which is the most crucial for me. This is where we ask each employee to think about their own role in improving flight safety. Why? Because an airplane requires the involvement of a certain number of areas, whether it be technical areas, regulatory areas, or customer relations. Thus, all employees are present in the available areas. And each one is asked to think about their own role in accident prevention.
I have a small question about quality. At the time, I had worked for Skywise on defining the use cases for big data. Digitalization is a key component of quality control security.
So not only at the level of quality control, but also in the operation of data in service. That is to say, when an airline reports an event to us, we can ask questions about the theme, but is this event, what is its frequency? Of occurrence between an event, let's say serious, very serious, which occurs once every 10 years, versus if Skywise tells us, no, it happens once a month. There we say in terms of exposure to risk, it's not the same story. So indeed, artificial intelligence, big data are very useful because of the volume of information we have. Whether it's internally for manufacturing to improve quality. The high number of incidents reported by airlines may be due to the size of their active fleet and the frequency of their daily flights.
I'm exaggerating, but we were waiting for the accident to learn from experience. Now the design office, it knows that there is a small gap through the big data.
That's the goal, and that's why we see this improvement. It's because we don't wait for events to happen to take measures. Whether it's recalling information to the crews, the mechanics, whether it's internally with our own mechanics, maintenance, we don't wait for an unfortunate event. We may need to improve a procedure or design for this maintenance. This is what the industry is increasingly leaning towards, and it's a good thing. And so each employee is invited to spend a little bit of time in front of their panels and reflect on their role, whether they are in design, in discussion with clients, in certification, in after-sales support, in training, in sales, all the
feedback that
we have with the customers, that we have with the customers. To explain why we introduced these basic modifications, which were not present in the initial plane design, to improve flight safety. When we introduced the runway overrun protection system,
it's a system that informs pilots about runway conditions like wetness and wind, risk of runway excursion.
Runway too short. So what does this tell the crew? It says, oops, maybe I need to do a go-around. The pilot's judgment can override other conditions, allowing them to continue landing despite potential issues. It's an indicator of the plane's performance relative to the remaining runway length. And to say to oneself, it's going to work or it's not going to work.
And so
that was not basic when airplanes first emerged. We introduced it, fully convinced it's a game changer, and we still believe that. To respond to the risks of runway excursion,
we decided to make it basic on our planes. Does that mean it's basic on new planes? But an A320, which was delivered a few decades ago, can we put it on?
Can we retrofit it? Well, it all depends. A few decades ago, it all depends on the architectural capacity of this plane, since planes have evolved. Not all necessarily have the ability to be retrofitted depending on the complexity of the systems. We strongly encourage retrofitting, which is viable in Europe. So here we come to the last panel, which illustrates the necessity of working together within an actor, Airbus, an airline, Air France. Also, between actors, between us and the companies, between the companies and their organizations, between us and the certification authorities, we all work together. As I mentioned earlier during our visit to the Safety Promotion Center, accident investigations have evolved over time. Initially, we focused on the technical aspects and what needed improvement. Then we gradually improved, as illustrated in this panel. We were looking at the technical elements. We evolved towards the human factor elements, the human factor and the systemic, the organizational factors.
In the 1950s, the technical factor was the only one we could effectively and quickly influence.
Exactly, beginning of the 70s, and it was accelerated with Tenerife. The human factor, whether in the interaction between crew members or in the design of the plane. And then it started in the early 90s, and we're really accelerating right now. Organizational factors, how a process, an organization, a change can potentially have an impact on flight safety. And that's really fundamental. All of this goes in the same direction with this idea that we have a regulatory obligation, but that's not enough. We have to go the extra mile. This is the meaning of this arrow on the maturity of what we call the safety management system, SGS system in French, flight safety. The idea is to tackle the three pillars of safety, transparent, safe. A safe plane operated safely in a safe environment. And so that's our day in English. Our quest is to work on these three pillars at the same time. As an aircraft manufacturer, we play a major role on the plane, but we think we have a role to play.
Also, sharing our experience with other actors is also why we'll hardly reach zero accidents, as we can't go to Cuba. Enforcing proper rule application in countries that lack internal control or willingness to correctly apply the rules.
That's true, a safe plane operated safely in a safe environment. And there you see all the arrows. Everyone is talking to everyone. And that's the goal. It's to have regional safety committees. It's to ensure that at the International Civil Aviation Organization level, the International Civil Aviation Organization, which governs the standards applicable to all countries, we can have constructive discussions to contribute, including for Cuba, including for countries that do not necessarily have an aeronautical heritage, as we can have in Europe, in France, particularly in the United States, etc. So it's really about working together, and we really see improvements,
including in these countries. On the other hand, I think of Russia, end of 2022. They authorized the implementation of uncertified parts on the planes they operate in the country. These are things we can't go to their place.
The context, everyone will agree, is very
particular.
Obviously. An important point that is the subject of much discussion, which is something that needs to be repeated constantly. Because we have newcomers, it's this notion of speak up, not being afraid to report a mistake so we can correct it. So it's part of the core values of Airbus Safety First, the safety commitment, speak up and sharing. I report something, we need to encourage the person to whom I report to share. I need to be encouraged as an employee to share this information and then to provide transparency and feedback. That's how we improve things. Simply put, Airbus is a big company. We know Airbus not only makes airplanes, but also helicopters. And then we are also in defense and space. We share this safety culture in all three divisions. It's really a common good. It's a common good. So it may seem surprising when we talk about defense and space, but it's important for the staff who operate our equipment. And then helicopters, just like for airplanes. When discussing flight safety, we covered it through the Safety Promotion Center, airplane design, and the role of each employee and their contributions. I mentioned manufacturing. Maybe a more specific point. We developed what we call the first classrooms for our mechanics on the assembly lines. It will talk to them about their daily life on the subjects, like foreign object debris, an object that is accidentally left in a plane or on a runway, a torque problem, an electrical wiring problem, a plane configuration problem, which are really the daily life of the mechanics. These risks must be avoided. In these first class rooms, we discuss the risks and their potential impact on flight safety. And there too, it's to reinforce this culture of prevention, and it works very, very well. And there too, as with the Safety Prevention Center, we have developed them at our various sites, whether in France, Germany, China, the United States, in Mirabel, Canada as well. Also a link with security. We work a lot with our colleagues from
the surety
in French.
Security, it translates to surety in French.
Surety.
Security.
Security, safety.
That is to say that here, it's the human factor, it's the will of terrorism, malice, global positioning system hacking.
Exactly, and the spoofing, jamming, hacking of the global positioning system, we talk a lot about it right now. And so we work closely together. What are the risks? What are the effects on planes? How can we remedy it? This provides a global view of our safety culture efforts, acknowledging that a culture of prevention is ultimately the same thing. Whether it's prevention of work accidents, whether it's prevention at the quality level, whether it's prevention at the flight safety level, it's really the same mindset. And that's what we push for, to constantly increase in maturity and constantly reinforce this mindset of prevention.
Well, Yannick, a big thank you. Thank you, Airbus. Congratulations on the results.
So thank you. That's why we're here, after all. That's exactly why we're here. And then it's everyone's business. Keep going. Thank you very much.
Friends, I hope you enjoyed this exclusive video at Airbus, and we'll see you very soon on the channel.